Hello, everybody. Welcome to the July edition of the Azure Functions Community Stand-Up. Thanks, everybody, for joining us. Um, I'm joined today by two great people here at Microsoft from the product groups. I have Ram from the Azure Data Explorer team and Drew from the SQL team. Um, as you know, Azure Functions has one of the biggest points of focus that the Azure Functions team has is on developer productivity. And a big part of it is our programming model and how we have triggers, input and output bindings. And today we're going to talk about two of them. There's one more live cast next week that will cover a third one that I'll talk to at the end of the presentation. But today we're going to get a great overview of the two extensions that we have, one for Data Explorer and then one for SQL. So with that, Ram, I'll let you take over and cover the first one for Data Explorer.
Sure. Very briefly, my name is Ram. I work in the open source connectors and custom extensions for Azure Data Explorer to bring data in and out of Azure Data Explorer of the store. Next slide, Thiago. Uh, Very quickly, Azure Data Explorer is a big data analytics platform that is optimized for ad hoc querying. It's fantastic for use cases such as IoT, for example, or log analytics and anomaly detection, for example, at scale. So that's really the key value proposition that Azure Data Explorer provides. It provides great time series analytics, and it provides a very interactive way of wrangling with large volumes of data. We use something called Custo query language, which is again an open source standard from Microsoft that is used for querying data from Azure Data Explorer. We ingest a few petabytes of data every day. It's battle tested on a lot of Microsoft workloads. Chances are that if you've used not used Azure Data Explorer directly, and if you've used products like Log Analytics or Azure Monitor or Azure Application Insights, all of them use Azure Data Explorer as the core exploratory engine for storing the data that we produce and providing insights out of it. So today I'll be very briefly talking about the input and the output bindings, which is a recent addition that we sort of did on Azure Data Explorer. So can we go to the next slide? Recently, in the Build conference that we had, we announced that we are releasing in preview the input and output bindings of Azure Data Explorer. The first versions have support for C#, Java, JavaScript, and Python. And as a first-class citizen, we offer support for managed identity as well with these bindings. The key value that we want to add here is integration with a lot of different triggers and connectors that are already there as part of the Azure Functions ecosystem. Just to add to what Thiago just mentioned, be it Service Bus, RabbitMQ, HTTP triggers, there is a wide variety of connectors that is available as part of the Functions platform. We really want our customers to sort of use these in conjunction with Azure Data Explorer. So that's been primarily one of the drivers for us to provide input and output bindings out of Azure Data Explorer. We've also provided Visual Studio bindings for Visual Studio support for functions tooling as well. And we also have PowerShell support coming for Azure Data Explorer bindings, just to answer the question on the chat as well. So that's very briefly about the roadmap of Azure Data Explorer bindings that we have. Can we just go? So very briefly, we've got input bindings and output bindings. If you want to select rows out of Azure Data Explorer, you use an input binding. So you provide a Custo query or a KQL query, as we call it, and then pass in a variety of predicates that we want to sort of use against these queries. So that's about the input bindings. And output bindings is when you have a set of data that's coming in from, let's say, a trigger or from another system of record that we want to sort of ingest into Azure Data Explorer. So those are the two bindings that we offer as part of our initial preview. Can we go to the next one? So To use an input binding, one of the key prerogatives that we had was how consistent are we with the other data stores of records. So for example, we already have systems like SQL Server that offer bindings, or Cosmos DB, another database that offers bindings. We want to provide a really consistent experience in terms of how these annotations look when we use these bindings in the Azure Functions framework. So you'll find that there are remarkable similarities in how these annotations look. Be it from SQL if you're already a SQL function user, for example, or a Cosmos DB function user. So Custo is the internal name of Azure Data Explorer. And then all that you have to provide for an input binding is a KQL command and the database to execute that again. So here, for example, we have got a very simplistic table, which is called products, and you have a predicate called product ID. So you would be able to pass a product ID in this case and then retrieve all the products that correspond to that specific product ID, for example. Again, a wide variety of binding supports is sort of extended as part of the initial revision. So for example, you could have an IAsync enumerable, or you want to have a JArray which you want to operate on, or you want to have a plain old CLR object that you want to sort of operate on. So all of these different types are also supported as part of the input binding. So the idea is to provide something which is a lot more simplistic like this, as opposed to writing a lot of boilerplate code, which is available as part of our .NET SDK, for example, or Java SDK, to provide something a little more easier, a little more low code to sort of use and leverage the functions framework itself. So that's been the key driver with which we have developed both of these bindings, and these annotations provide a good example of why we do that. Can we go to the next one? So the next one is the output binding, the reverse direction, where we want to output a record through Custo, for example, into Custo. So here, for example, I've got a target table name which is called products, and it's in a database called DB, for example, and I want to ingest, let's say, a plain-old CLR object in this case, which is product, or a JSON, or a list of products that I want to sort of ingest. What it also offers is, if we have data coming in the form of triggers which are not in JSON format, and if we want to, let's say, use CSV, for example, we also optionally take in a data format which sort of provides an option to provide other forms of data. There are a wide variety of data formats, text and binary, that are supported as part of ADX. So you would be able to optionally provide a data formats, for example, and then use that to ingest the data as well. And if you want to have a database ingestion mapping, for example, you want to, let's say, map last name to LN and first name to FN, for example, in your database, you would be able to do that by passing in mapping references as well. So not all the options are listed really in the annotation, but they're part of the documentation, and you'll be able to use it a lot more flexibly, should I call it, when you're actually using it for a real use case. I'll very quickly go to the next part, which is a very quick demo that I sort of have. So I'm going to very quickly present my screen here for the demo. And let me know once you can see it.
Yes, we can see it now.
Sure, thank you. So the samples that I'm going to quickly walk through are samples that are present as part of our open source repo here. So here, for example, I'm going to walk through a couple of demos of input and output bindings very quickly, how we ingest data and then sort of retrieve data using input and output bindings. So these are available as part of our samples for C#, which is present in our open source GitHub repo. You can check out this link. And I've deployed these on an Azure Functions, on the portal, on Azure portal, and I'm going to use these, which are wired to HTTP triggers, to sort of very quickly show how we can do ingestion of rows, be it a single row or multiple of rows, and then we can sort of query these out of ADX as well. So here, for example, I'm just doing a very simplistic case where I'm adding a product, and this runs exactly the same code that you see here on our GitHub repo. So quickly, if I were to quickly check this and the product that we inserted, this is just a query language. Of course, I've got a table which is created here, which is called products, and it contains these three columns. As you can see, this is the row that we sort of inserted right now from this HTTP trigger that we have, which is a 05 record, for example. We could also do multi-product ingestion. That is, you could have multiples of these products that are sort of ingested as well. That's another solution that we have, where we've got multiple of these product rows getting inserted into the system. So quickly, you could have an array of these products that are sort of sent in as well. So here, for example, I've ingested a few additional rows here. And I'll be able to query these from the system as well. So for example, I could simply say between 100, these are the list of rows that I've sort of inserted into the application. So you will see that the rows that we sort of ingested appear here in this configured database that we have. And the configuration really is just very simplistic. All that we have to provide is just a Custo connection string placeholder, which is provided as part of the configuration. You just provide a Custo connection string, which is a well-documented connection string like all the other products that we have. And we use that to sort of just establish a connection with Custo. We support both managed identity as well as application AD credentials. So this is about ingestion of data. Now, when you want to get data back, for example, you could actually use something very, very, very similar as well. So the example that we had, where we had an additional predicate, given a product ID to query the product back, for example, this is exactly that use case. So this is the row that we just inserted as part of our previous, demo example. We're just going to retrieve these rows as part of our input bindings that we sort of do here. So this is the same row that we ingested and we sort of queried from Azure Data Explorer. Quite similar to this, you can actually write functions on Azure Data Explorer, quite similar to a TSQL stored procedure or a function that you would write in a database. And the good part is the bindings allow you to transparently call a function as well. So for example, you could actually have a function here called get products by name, which is sort of defined in in the ADX side. A get function, get products by name is the name of a function that we have, and then you can use this function to sort of retrieve data from the system as well. So a lot of flexibility is offered in terms of how we want to query the system and want to insert rows into the system. So this is the first version that we have as part of our offering. What we want to do is we want to build on this capability. We want to have a few more features that are sort of coming in as part of the next releases that we have. One is, of course, we want to support control commands. So apart from normal ingest and query commands, we have a lot of dot commands, which are, for example, you want to import data from an extra source, or you want to export data to, let's say, a storage account. So these are called control commands. We want to support control commands, for example, in one of the next releases that we have. We want to provide support for direct ingestion from blob storage. So the blob annotation that we have on the Azure Function framework is great. We want to be able to watch out for blobs that are coming in as part of blob triggers and directly ingest this blob into Custo, into ADX, for example. We also want to add support for client request properties. So if you want to, let's say, set your custom timeout, or you want to control the number of records that are retrieved as part of the query, all of these are possible through something called client request properties. We want to be able to provide customers to enhance the bindings by using client request properties as well. So these are next steps that are coming as part of subsequent releases from Custo, from these bindings, for example. And all of this binding, as we just saw, is available on GitHub, and there's a lot of documentation that we have sort of added as part of the first preview release. We'd be happy to help if you have any questions at all. We actively look at that GitHub repo. If you have any questions or any issues, you can obviously reach out to us, and we'd be very happy to help you with this. Over to you, Thiago. I think that was the main points that I wanted to cover.
Right, thank you, Ram. And here on the screen, you should see some links to references. So, like he covered the extension is fully open source. All of the Azure Functions extensions are. This is the one for the Data Explorer or Custo. We have a aka.ms/adx bindings docs as well for the documentation. There's some more scenarios and other documentation as well on the Data Explorer pages. And finally, some samples are under the same GitHub repo as the extension if you want to check out the sample that Ram just went over. And I know that we had one question that came up that was support for PowerShell. So maybe you can tell us, the languages that we support and the plans going forward for it as well.
Sure. The first set of releases that we had support for, apart from C#, we had support for Java, we had support for Python and JavaScript. We are in the process of adding support for PowerShell as well.
Okay.
We should be able to get that in the next month or so out as well. So we should be able to add support to that in the coming
Sounds
releases.
good. Thank you. Yeah, this is super exciting.
Thank you.
And now we will pass it over to Drew to cover the SQL extension that we have. Take it away, Drew.
Thank you, thanks. Thanks, Ram. Yeah, I think one of the things that Ram touched on about we've got different functions bindings for different data providers, and there's consistency across how you learn to use them. So once you've used Cosmos bindings or SQL bindings or the now Data Explorer bindings, you've gotten to know a lot about using functions, and you're going to get that much faster. One of the core things that Ram showed where your connection string goes in the app settings is fantastic because it means that your connection string is never in your code. And that's just one of those best practices that we're really trying to encourage through how we have set up these different data-oriented bindings for functions. Real quick, similarly for the SQL bindings to what we saw for the Data Explorer bindings, there are input and output bindings. For an input binding, you're reading data out of the database into the function. So when the function runs, you get an object in the function that it contains the query results from your SQL database. And then the output function is an object from the function at the end of its execution gets written into a table specified by SQL. One of the not always real intuitive things about input and output bindings is that you can have more than one. For example, if you are writing a order to a database, so you have a header row and then you have detail rows, you can put two output bindings on your function, one for the header table and then the other for the detail table, and you can add multiple rows at a time in that detail. So when you're thinking about input and output bindings, don't necessarily think of them as a one at a time thing. You can stack them and have multiple on the same function to get richer functionality. Now, the SQL Trigger is currently in preview. The input and output bindings went GA at Microsoft Build, but the SQL Trigger is still in preview, and it is an area of a huge amount of excitement because this is a complex topic within the space of databases. How do I respond to data changes? With SQL database, whether it's Azure SQL Database or SQL Server, when you hear the word trigger, you might go, "Oh no, why? Why would you do that?" If you're thinking about the trigger within SQL, that response comes from the trigger within SQL blocking the transaction that's trying to run. So if you're inserting a row, then it's going to slow that down. This is not that. This is not that. I cannot repeat that enough. What the Azure Functions SQL Trigger is it is an application layer on top of change tracking in that SQL database where the function itself checks at an interval that you set. It defaults to every second, but you can extend that out, and it checks for unprocessed changes. This is the extent of the load on the database. It's just going to check and query that table real quick as soon as the function processes whatever results, and not like running the entire function, just reading them into memory. So this is very, very quick. There's no other, there's no blocking on the database beyond that results reading. It really is as heavy as if you were to open up SSMS or Azure Data Studio and run a quick query against that table. That's the extent of the load. So you're not blocking the rest of your transactions. Your database is free to be a transactional database. Once the function has those results in memory, if there were results for data changes, then the function runs whatever it needs to do on them. So you could have output bindings, you could do other calls. You've got all the flexibility of Azure Functions now, but with the changes that happen to your database within that interval. This is exciting. As a developer looking to be able to respond to data changes, whether it's an insert or an update or a delete, I now have an Azure function that is watching my database and doing something with those data changes. That's pretty darn cool. Now the kicker for the SQL bindings for Azure Functions is they're called the Azure SQL bindings for Azure Functions, but what gets me so excited about this for developers is it's great to come out with new features for the latest Azure SQL database or the latest version of SQL Server, but it warms my heart to bring an opportunity for developers that is super compatible across Azure SQL database, Azure SQL managed instance, and SQL Server all the way back to 2016. So you don't have to worry nearly as much about which SQL am I using, as long as you have connectivity to Azure Functions, and you're at compat level 130, which is 2016 or higher. You're able to use SQL bindings and SQL Trigger. It's kind of open season there on whether or not you can use it. The trigger, I did mention, uses change tracking. So you would enable change tracking on that table and then make sure that you have the auto cleanup on the history table enabled at a good interval for your workload. But this means that kind of no matter what transactional Azure SQL or SQL Server you're using, you can then tie into SQL bindings. The last thing that I wanted to touch on before I dive into a quick demo is the use of managed identity and how, frankly, pretty straightforward it is to set up for SQL bindings. We talked about it with Data Explorer as well, but managed identity is so important because not only are you not putting your connection string in your code, it goes into app settings for Azure Functions, but you also don't even have a username and password in your connection string at all. The Azure Functions instance itself, its identity gets added to your SQL database as a user, and it says this Azure function has access to read from these tables, or this Azure function has access to write to these tables. And then your connection string is just the server name and the database name, and then that it needs to use managed identity. There's no username and password. The risk and the security, the risk reduction and the security that comes from moving to managed identity is fantastic. And so I can't advocate for it strongly enough that you consider using managed identity for your app connectivity into SQL, but then also look at how easy it is to use with Azure Functions and the SQL bindings. So I'm going to pop my screen up and then talk through a quick demo using SQL bindings and the SQL trigger. Awesome. Okay. We have our friendly Clippy here. And what this is a website. It's a Azure Static Web App I've kind of been developing locally here. I've got a nice emoji and then a couple categories over here. And if I select a category, all of a sudden the page populates with more information and there's a form. And you guessed it, there is a SQL database behind all of this. So I have a static web app on one side and a SQL database on the other. And anytime someone says I have APIs behind a static web app, you know that it is Azure Functions. So that's what we have going on here is I have a couple of Azure Functions. Oh, my screen didn't change. Okay. I'm sorry, hold on just one second. It looks like my screen isn't grabbing everything. There we go. Now I will there's VS Code. I didn't want to just stick in a browser. That was my fault. So we know that we have Azure Functions behind our Azure Static Web App, and this is what is talking between our static web app on the front end with our good friend Clippy and VS Code. So we've got VS Code here that is running the functions runtime as well. So I'm doing a lot of local development. Even my SQL database right now is in a container on my local machine. I could bring that out to Azure when I'm ready to deploy, but I want to do local development. So a real quick overview of some of the APIs that are serving that front end. I've got a category list API that's a GET request. So that is this little box here. This is dynamically populated. What that looks like as a JavaScript function is kind of boring. I always hesitate to start with this really boring example because you're like, yay, you put an object in a response body and it gets populated by a SQL binding in my function JSON. So it says I'm a SQL binding, I'm an input binding, and I'm going to run a query. It's simplistically beautiful, but it is also, it can lead you to a false sense of limitation for SQL bindings. Like, this is not all I can do. This is just how easy it is to get started. So let me step beyond that, because we've loaded up our product list. When I click on that, it gives me a list of products. But I have this little details button. And what this details button gives me is it gives me a pop-up that runs a stored procedure and outputs the results of this is how many products were sold in the last year. Obviously, that stored procedure knows what product it's supposed to run for. If I go back to VS Code, my product sales summary API request was for the product ID 877. What was happening there? So I have a function binding where the route product sales summary takes in a parameter. And we saw this with the Data Explorer bindings as well. You can pass parameters through. It could come from your HTTP request. It could come from another trigger. And in this case, I'm passing the @product ID parameter right into my stored procedure. So instead of running a full-on query, I'm running a specific stored procedure within SQL. And the result of that is what gets passed back. And I can even check things about it. So I could see, oh, I had no orders. And so instead of responding with HTTP 200, I'm going to say 204, just for the variety, the spice of life there. But this gives me now a more dynamic web interface where I can do different things based on specific objects. But what about adding a product? So we've talked a lot about input bindings for a few minutes, but what about adding a product? This is going to be an output binding. I want to take an object from a function and put it into a database. Why this can be particularly interesting is not about the function binding definition. That is boring. You give it a table name and you say, this is the object product that the data will be in when the function is done. When the function is done. During the function, you can do other things. So at the end of this function, context.bindings.product is what is inserted into the database. But what about everything before that? When the front end passes information to my API, maybe I don't trust that information. Maybe I want to set some default values, like this was the last modified date. Maybe I need to generate a GUID or do a little bit of data cleaning. Say, hey, if the weight is going to be 0, then we need to set it to null. So you can do additional operations in your app layer instead of at the database layer. Databases are really good in working at sets. Like if I'm going to operate on 100 things, that's great. But if I just need to do a quick number of linear operations, Azure Functions is a great place to do that before outputting it to the database. So that was kind of what was going on the front end here. The other side of this little demo takes a look at the SQL trigger. Now, in this hypothetical Contoso company where they're selling these products, they have sales orders. And when a sales order is entered, they want to be able to respond to that by sending that information somewhere. If I had planned better, I would have had a SQL trigger outputting to Data Explorer, but I didn't. I've got a SQL trigger that when an order is added to the database, it sends it out to event hubs. You could send it out to event hubs and then have event hubs pass it on to Data Explorer or even your Azure storage as Parquet files. You can output directly to these things. But what I want to show real quick is kind of how quickly this response happens. Now, I don't have a front end interface for entering orders, so we're going to have to do it the old-fashioned way. We're going to have to run a query. We're going to run a query that inserts 3 sales orders with a bunch of products on them. But before we do that, what the product new product trigger looks like from a code standpoint is it has 2 bindings on it. The first one is the SQL trigger. And this probably looks pretty familiar at this point now that you've listened to me talk for about 10 minutes. We've got a connection string setting. We've got a table name that we're watching, and then it's a SQL trigger. You're not having to write a whole ton of custom code to like get this driver and query a table and then handle that results and hopefully close the connection. Like this is the amount of connectivity code that you need. Similarly, I mentioned I'm outputting to Event Hub. This is an Event Hub output binding, pretty straightforward too. Within the JavaScript code that uses this SQL binding, I've done a few little tricks to make sure that we can see it in our functions output when we insert the new orders. The first thing I'm going to do is just show all the changes that have come through. What we can do when we have a set of changes is we can process them one at a time if we'd like to. And particularly, I mentioned earlier, we get inserts, updates, and deletes. If someone has gone in and updated an order, I don't necessarily need to do something about that. But in this hypothetical situation, I really only want to look at new orders and then log those to Azure Blob Storage. So I'm going to make sure that my operation type is 0 for new order. And then I'm just going to take that data, the sales order header data, turn it into JSON and pass it off. So I can say, I want to push this somewhere else where I can handle it downstream. And so I will go ahead and push that new order to my service bus there. That is running in the background. It's been running this whole time. So I'm going to go ahead and run the insert, and then we'll come back here and see if we see our new order alert, and then we'll check Azure Blob Storage and all that. And I'm going to kind of try to click through it so you believe me that this is happening quickly. Ran the query. New orders. That happened. Okay. Oh, I'm falling behind. Ooh. Not fast enough. Did my service bus fall asleep? Service bus should have gotten the results and be parsing it. Let's see if it picked it up yet. Yes, there it is. So it gave me like a 30-second heart attack while I waited for service bus to pass this off to blob storage. But there's our latest Parquet file of those new orders that we added. So that was pretty quick of me like hopping around screens. And keep in mind, I'm running all of this locally except for the service bus. So that was probably the delay. When you're designing your Azure architectures, a lot of times you co-locate things in the same data center. I set the service bus up on the East Coast of the United States, and I am not on the East Coast. So there was probably a 10-second delay from the network traffic there. So yeah, pretty spiffy to process our results so quickly and with very little load on the database as orders are being entered in general.
You mean event hubs, right, Drew?
Yes.
Okay.
Sorry. Yes. Yeah. Those are event hubs. Good deal. Well, with that said, I do have the links for just SQL bindings in general and the SQL trigger to share with folks. The SQL bindings code is also open source, and on that GitHub repository, the team of engineers that works on the project love responding to questions. We definitely check in with people there pretty frequently, and then there are more samples linked into the documentation as well. And so there are samples for all the languages in the GitHub repository. So that does include the C#, Java, JavaScript, Python, PowerShell. C# is both in process and out of process. So it's fully supported from the input and output binding standpoint. SQL Trigger is still in preview, but we're looking to bring that GA as soon as we can.
That is great. Thank you, Drew. One question that I had in mind is for the trigger you mentioned. So all the changes, insert, deletes, updates, they all flow through to the function. Is there a way to filter that before it gets to the function, or at the moment everything gets sent to the function, you filter inside the function?
Right now, it is only when everything has gotten into the function. It pulls all of the changes into the function, and then processes them from there.
Okay, and that's how the trigger itself, not the trigger, but the
change tracking. Yeah.
Okay.
Yep. So change tracking is going to track all the changes that have happened to the table, and that's what the trigger kind of absorbs out from. You could do maybe a chain of functions if you want to keep one really simple that gates out those changes and pass on to another.
Right.
But certainly, yeah.
Cool. All right. Yeah. Thank you both. Thank you, Ram and Drew, for presenting today. There is a third new extension that we have for functions for Redis, but we have another event next week on 25 of July at 10 a.m. Pacific time zone. So please, follow the link as well and check in next week, where we're going to go deeper into the Redis extension. And then with those three, we'll have gone through the most exciting latest updates to the functions, triggers, and bindings that we have. With that, that's all the content we have for you today. I really appreciate you joining our live stream, and look forward to having you join us next month for another great topic. We'll send out the notifications on Twitter and LinkedIn and other locations as we get closer. With that, thank you, everybody. Thank you, Drew and Ram, for the awesome presentations and demos as well.
Thanks, folks. Take care.
Bye.